Have you ever wondered how our mind creates our behavior? Well, that's what I want to understand. But this question of how our mind is related to our behavior isn't just important for our curiosities, but it's actually important for understanding mental illnesses, since many mental illnesses also have abnormal behavior. For example, in Parkinson's, it's often associated with tremors, where in dementia, patients often have trouble navigating through a task or navigating through a room. What underlies these behaviors are billions and billions of spikes in our brains which encodes the behavior. So if we can understand what these spikes are saying, then we'd understand more about the mental illnesses. A simple place where we start is looking at a simple model of a rat reaching for food, which is what I did in my experience. Even with this simple rat reaching for food, there's still billions and billions of spikes which encodes this simple behavior. Once we have these spikes recorded, we can feed it through an AI which generates frames of the video of the rat reaching, which creates a fake AI video created just from the spikes. Why we would want this is so we compare it against the real video of the rat reaching, and we could see which features of the video and the rat reaching the spikes are able to recreate and what features it wasn't able to recreate. In terms, we could tell what the spikes contain, what kind of information the spikes contain, and what kind of information it doesn't contain. This isn't just about understanding how rats reach, but it's more generally to understand how species' motor cortex communicates with its behavior. And so we can understand more about the mental illness. Where this is mostly applicable is in industry, where companies try to restore motion impaired patients' movements by tracking limbs, many limb trackers on their body, and try to recreate those positions through their motor cortical spikes. But a limitation in this is that those spikes might not have the full context of what the patients are doing. For example, the motor cortical spikes might also contain information about its body position, or its environment, or the task which the patient is doing. And so a video analysis, like in my study, will be able to improve the reconstruction of the movements and also help the motor impaired patients. I think we're in a new era of science and health driven by AI to truly understand the contents of the mind and brain. Thank you.